Okay, so today's lesson we're going to focus on isosceles triangles. So we spoke a bit about them a few days ago in our lesson, but the true definition of an isosceles triangle is a triangle with at least two congruent sides. So make sure that you're writing the definition and actually draw this triangle big enough because we're going to begin labeling that triangle with a bunch of different parts. So the two congruent sides that we have are called the legs. Okay, so we have two legs. And then the base is not one of the legs, so the base is always going to be the third side. So we have the base. Okay. And we also have a vertex. So here, A is our vertex. And then right in here, this is our vertex angle. And so we have our vertex angle, but then we also have base angles. So these two angles coming up from the base are the base angles. Okay, so we have two legs, a base, two base angles, and then we also have a vertex angle. So we're going to discuss something called the isosceles triangle theorem. And if you didn't get all that other side, then feel free to scroll back and you can write that down. But if two sides of a triangle are congruent, okay, so if these two sides are congruent, then the angles opposite those sides are also congruent. So if we're looking at this diagram, if we have segment AB is congruent to segment AC, then the angles opposite those sides, angle B and angle C, will have to be congruent. So I would pause the video and make sure that you write it down. If you want to draw a smaller picture, you can say, okay, those two sides are congruent, then the opposite angles are going to be congruent. So this is the isosceles triangle theorem, and we can abbreviate this as ITT, isosceles triangle theorem, and this shows up quite a bit. So sometimes theorems are stated backwards, okay? So if they're stated backwards, it's called a converse theorem. We're going to talk more about that in our next unit, but for now, we're going to call it a converse theorem when we jump into the isosceles triangle theorem converse, which we can abbreviate as ITTC, isosceles triangle theorem converse. So this is something different. So let me just go back. Notice how we have if the sides are congruent, then the angles are congruent, opposite. This one is if the angles are congruent, then we know that the sides opposite those angles are congruent. So then we could say AB segment is congruent to segment AC. So it's just backwards. So if we know that two corner angles or two base angles are congruent, then the sides opposite those are congruent. And then from the previous one, we have the isosceles triangle theorem. If we know the two sides are congruent, then the angles opposite those are also congruent. So pause the video, make sure you have this all written down, and we're going to do some practice problems. Or we're going to talk about properties first and then do some practice problems. Okay, so in an isosceles triangle, we have altitudes and medians. So if we have AB and AC are congruent, we also know that angle B and angle C are congruent. Okay, so I'm telling you it's an isosceles triangle to begin with. So segment AM is an altitude. So if it's an altitude, what do we know about that? And AM is also a median. So what do we know about that? So everyone's thinking, have a thought in their head. So since it's an altitude, we know that it creates a right angle. So the angles that are congruent are these 90-degree angles here. So angle AMB is congruent to angle AMC. Okay? And it's also a median. In an isosceles triangle, this altitude is also a median. Therefore, it splits the base up into two congruent parts. So BM is congruent to CM, those segments. Okay? So this is a property of isosceles triangles. And then the last property is that AM bisects this vertex angle. Therefore, if it's an angle bisector, it splits it into two congruent pieces. So angle BAM is congruent to angle CAM. So we have properties of triangles. Notice how they're mirror versions of each other. So like this triangle and this triangle, if we look at the two, they are mirrored. We could cut them in half and we can flip them around and they would be the exact same triangle. So feel free to pause if you still need to write this down, but if you don't have to pause, then we're going to move on. Okay, so these are classroom problems that we're going to be completing together in class tomorrow. I want you to give a time, or I want you to take some time to try these on your own. So I want you to complete these problems. I'll go problem by problem, but pause the video and complete each problem. And you don't need to write out the problem, like you don't have to write this out, but I would suggest drawing the diagrams would be a good thing to do. Okay? So make sure you're drawing the diagrams big enough so you can write in them. But this is the first question. Triangle GHK, this triangle here, is isosceles, and the base is GK. Right? So that's our base. So if we know that's the base, we need to think about what the legs are. And the legs are always congruent. So you can use that to help you. And then we also know that there's another isosceles triangle, triangle HJK. HJK is isosceles, but the base is HK. So think about where the legs are located. And if you know that the legs are congruent, then what angles are congruent, and use that to help you. Okay. So I'm going to just erase my information here so you can draw that diagram nicely. So I want you to pause the video and try this out. We'll be checking them in class next time. And now I'm going to move to the next one. So you don't need to draw this diagram, but I want you to complete the problem. You can draw the diagram if you want to draw on the diagram and mark some things, but given two congruent angles, name two segments that must be congruent. So we want to look for triangles that have these angles. So if we do part A together, let's look at this together. So angle 1 is congruent to angle 2. So I want to ask myself, what triangle has angle 1 and angle 2 in it? And notice how it's this triangle that I'm outlining here. So if we know that's the triangle we're looking at, and angle 1 and angle 2 are congruent, then what segments must be congruent in that triangle? Okay, so pause the video and do part A, B, and C. And then when you're ready, you can hit play to move on. Here's this third problem. You can use a calculator. Notice how we have tick marks on here. So these, if we can't see them, those are all congruent. These are congruent. And then we have the 50-degree angle. Okay. You don't have to draw the diagram, but you can if you want to, if it's helpful. And I want you to find the measures of all of these angles here, and you can use a calculator. Okay. So pause the video to complete the problem. And then when you're finished, hit play to see the next problem. Okay, so here's the next one. I do actually want you to draw these diagrams. We want to find the value of x in each of the diagrams. So draw each diagram in your notes. For each problem, determine which side or angles are congruent. So use your knowledge of isosceles triangles. So here, if I just mark what I know for the first one, I know that this side is 10 and this side is 10, making those two angles sides congruent. So if those sides are congruent, then what angles inside of that triangle are congruent? And see if you can use that to help your knowledge or to help answer for x, find x. So notice that we have a 10 here for the next one, and 11, and then we don't know what x equals. But we have two angles in here. Can you find that third angle? Maybe that could help you. So pause the video and complete these two problems. And when you're finished with these two problems, make sure that you upload your notes, and we're going to check these problems together with partners in class tomorrow.